Well, hello students. Professor Coates here, bringing you another video presentation on the CIS 116 Chapter 8 assignment. This is the second part of a video series on this assignment, and I'm going to pick up where I left off in the first part. There were two issues that we left off with when we concluded the first video. The first issue was that when we displayed the savings data, that it was not sorted in descending order by month from highest to lowest. The savings values were presented in the order of the months, January through December. The other issue we had was we were having a difficult time displaying columns of data, like a table-based format. So I want to show you the way I handled both of those issues here. And I'm just going to, instead of writing the code out, I'm just going to take a completed solution here and walk you through the code. So first of all, I'm just going to run this program so you can see how it works. Okay, so how much will an upgrade for a single hotel cost? I'll just put 1,000 here. And then I'll just start putting in some data that is somewhat sensible here. It should be less, well, I guess I really can't say it's going to be higher or lower at any given time of the year. You could argue that in the holiday seasons, the cost will be greater, but whatever. It doesn't matter too much what the data is. So as long as we can see a savings. So I'm going to try to make my second set of data smaller than the first set. And if I can stay under 100, then I should be more than adequate here. So okay, so you look at this result here. After you've entered the data, it says here is an analysis of your data, and I'm displaying the month and the savings amount, and you can see that the months are all over the place, but the savings values are in descending order all the way through August, in which we didn't save anything because I must have entered the same two numbers before and after. And then it says it will take you 1 year to recover your investment. So that's the program, and it seems to be working fine. So what do we do? Or what did I do to change it? Let's take a look. So at the top, nothing really changed up here. Created the array to hold the costs before the upgrade, and another array for the costs after, a third array for the difference or the savings, and then a fourth array to hold the names of the months, which we initialize with all of our month names here because we know what they are, they're never going to change, and it's easier just to initialize them when you know that. This accumulator variable, whenever you're adding data up into a sum, we call that an accumulator. So the accumulator here, total savings, we're setting to 0. Then we're asking how much will the upgrade cost for a single hotel. We're going to store that as upgrade cost, and this block here will check to make sure that number is greater than 0. Then we have our loop where we're asking for the monthly water bills before the upgrade. We're putting those in an array called before install, and we're validating as we go so that the numbers are positive. We do the same thing for the after values. Then this block of code here calculates the savings per month as well as the total savings by adding up in each individual monthly savings amount, which is calculated as the difference between before and after. Now, I did switch these two arguments here in my revision in this video because I was finding that the numbers were coming out, the savings numbers are coming up negative because I was taking after and subtracting before. What you really want is to take the before number and subtract the after number because the before number should be higher than the after number, and you want your savings values to be positive. So I switched those two around. Now my savings array will be set with hopefully positive numbers. If the water bills were higher after the upgrade, it doesn't necessarily mean that the upgrade failed. It may have just been especially busy months. So that's why we do the whole year, to try to estimate as best we can over the course of an amount of time how long it will take to recoup our savings. Our investment. Okay, so once we're done with that, now I'm going to be sorting this savings array in descending order. Now, the way it is right now, I have two arrays. I have savings and I have month names. We call those parallel arrays because they work together. The first element in savings corresponds to the first element in month names. The first element in month names is January, and the first element in savings is the savings in January. The second element in month names is February, and the second element in savings is the savings amount in February. So if we're going to shuffle these values around in savings here, we want to take our parallel array and shuffle that the same way. But I don't want to mess up my original data. So what I do here is I clone my original arrays. So I take my month names and I clone it. So this clone is a method of an object, of an array object specifically. So month names is an object, it's an array object. I tell it to clone itself and it gives me back a copy, which I call sorted month names. And I do the same thing for savings, calling it sorted savings. Of course, they're not sorted yet, but they're identical to the originals, and now I can start working on them. What happens next here in this loop, this is a traditional sorting algorithm. It's not very efficient, but it's easier to understand. What it does is it generates a nested loop. So the outer loop holds I from 0 to 10, which is one less than the endpoint of the array. There are 12 values. 0 to 10 will give you 11. Then inside of that loop, we have another loop where my control variable is called j, and it starts at I plus 1 and goes to the end. So the first time through, I will be 0. J will go from 0 plus 1, or 1, to 11. So what you're doing is you are taking a value in the array at the beginning and comparing it to all of the values to its right. If you line them up in ascending order from left to right, I shouldn't say ascending order, let me rephrase that. You take your array and you take each element and you put them side by side from left to right. You take the first value and compare it to all of the other ones to its right. And if you see one of the values on the right there that happens to be greater than the one on the left, you swap them. So if I find that there is a savings element j greater than I, then what I do is I create a temporary variable. I take the value in the right-hand element stored in temp1. Then I take that right-hand value and overwrite the left-hand value with what's in the right-hand side. Then I go back to the left-hand side and write into it what was on the right-hand side. So again, I have two values, one on the left, one on the right. The one on the right is greater than the one on the left, and I want to swap them. So I take the one on the right, store it as temp1. Then I take the one on the right and I overwrite it with the one on the left. So I've done half of my swap. Then I go back to the one on the left and overwrite it with the one that was on the right side. But now it got overwritten, but I stored it before I overwrote it in this variable temp1. Now this swapping algorithm is carried out on the month array as well, using the same index values. Now, the months are not greater than or less than one another. However, since the savings values are, I'm just going to take the month names and sort them the same way. When this nested loop completes, then I will have a sorted savings array and a sorted month names array, and they will be in parallel with each other, just as the original arrays were. Now, at this point, I can take it from here and finish things off. Take the upgrade cost, divide by savings, take that division and round it up to the next highest year to break even. Now, what I'm doing here in this section is I'm saying, here's your data, and what this does in Ruby is it prints out a string and it pads it 20 characters. Now, the negative means that it will pad it, it'll put the padding on the right side. So if May takes up 3 characters, then we're going to have 20 minus 3, or 17 spaces on the right side. So you're going to get your names of your months, and they're going to be padded as appropriate up to 20 characters. That will give me a lined up set of columns for my data. The second column will just be the savings amount. So I'm just using %s. Now, if I wanted to do the 2 or 3 columns that I talked about doing yesterday, I could just do the same thing here. I could say, well, okay, how long is a savings amount? Well, let's see, we could count up 1, 2, 3, 4, 5, 6, 7, 8. So let's just make it an even 10, and I could put negative 10s here, and then do another negative 10s here, and I could set up multiple columns, and they would be padded and look great. In this case, I only did 2 columns. This is the header. So the first column, it'll actually print the word month, and the second will say savings. This next line prints out 30 hyphens. So it's hyphen times 30, which is a trick in Ruby of just saying, give me 30 hyphens. Then I have a loop that goes from 0 to 11 for my months, and I'm going to print out the sorted month name and pad it with 20 spaces if needed, up to 20 to the right of it, followed by another space, followed by another value, which %s is a string. Sorted savings is a number, but I call toCurrency on it, and it formats it with the $sign and the commas and so forth, and Ruby sees that as a string, and so I display it that way. So this will give me a nice looking table of results, and then at the end I tell them how many years it will take to break even, and that's it. So hopefully this makes sense to you. This swapping algorithm is probably the trickiest thing in here. If you want to try to work through it and understand it, one way you can do this is to set up a simple test case and set up your first array, and then just put some values in, whatever, just some random values like this, and then pretend you're the computer, and start working through the algorithm using this data and put it on paper and do the swaps and go through the exercise of carrying this out so that you can see how it works. That's the best way to understand an algorithm, is to pretend you're the computer and to solve it yourself. Now, you may not need to actually carry it that far. You may be able to see it in your head abstractly without writing it out. That's a skill that you acquire over time. But this algorithm, as I say, it's not the most efficient algorithm in the world, but because we have to sort 2 arrays at the same time or in parallel, we have to do it this way. So I hope this sufficiently explains the changes that I made to make this program work the way it should. And if you have any questions, email me or post in our virtual office, and I'll do my best to help you out with answers to them. That concludes our presentation. Thanks for watching, and I'll see you soon.